class, for today we will be discussing parabolas with vertex at HK with the following objectives. First, determine the vertex, focus, directrix, ends of the latus rectum, and axis of symmetry of the parabola with vertex at HK, and of course sketch the graph after determining the elements. In one of my videos uploaded, I derived the standard equation of the parabola with vertex at HK and opens to the right. Let us consider this figure and let's have a recall on the parts of the parabola. So in this figure, the vertex is at HK and the focal distance, which is denoted by A, is denoted by A. So the coordinates of the focus for this parabola would be H plus A, K. So since the distance from the vertex to the focus is A, therefore, by the definition of the parabola, the distance from the vertex to this point on the directrix is also A. Thus, the equation of the directrix would be x equals H minus A. Next is the axis. The axis is the line of symmetry of the parabola. This means this is perpendicular to the directrix and passes through the vertex and the focus of the parabola. So in this graph, the equation of the axis is y equals k. Then another element of the parabola is the latus rectum. Take note that, as we discussed last time, the length of the latus rectum is equal to 4 times its focal distance. So let's say we have this latus rectum for this figure. Okay, we have the ends of the latus rectum. So the length is 4a. So what would be the coordinates of this point? Considering that the focus has coordinates h plus a, k. Okay, so let's say this is L. What would be the coordinates? Okay, so that would be h plus a. This is 2a, right? So you'll have k plus 2a. And then for this point, let's note this one as R. The coordinates would be h plus a, k minus 2a. Okay, since it's also 2a. So in the video that I have uploaded, we derived that the equation of the parabola with vertex at HK, axis parallel to the x-axis, is its equation, its standard form is y minus k quantity squared equals 4a times the quantity of x minus h. Again, this is the equation of the parabola with vertex at HK and it opens to the right. Now, what about the parabola that opens to the left? What do you think it is its standard form? Okay, so that is y minus k quantity squared equals negative 4a times the quantity x minus h. Next, what about the equation of the parabola that opens upward? Its equation is x minus h quantity squared equals 4a times the quantity of y minus k. And the equation of the parabola that opens downward is x minus h quantity squared equals negative 4a times the quantity of y minus k. These are the standard forms of the equation of the parabola with vertex at HK. Now let's have some examples. Let's have our example number 1. The given equation is y minus 3 quantity squared equals negative 8 times the quantity of x plus 2. So for us to graph and determine the elements of this parabola, first is you have to check whether the equation given is in standard form. The question is this in standard form? That's right, it is. So since this equation follows the standard form, y minus k quantity squared equals negative 4a times the quantity of x minus h. Therefore, where's the opening of this parabola? That's right. The opening is to the left. So now we can determine the value of the vertex and the value of the focal distance, or the value of A. So what is the vertex? We have negative 2, 3. So this is our H and this is our K. Then, what about the value of A? So the value of A, since negative 8 is equal to negative 4a, therefore the value of A is equal to 2. These are only the things that we should know, guys, before we can graph and determine the elements. That's just one of the strategies. Okay, so we have the value of A is 2, the vertex is at negative 2, 3. Then you can immediately proceed to graphing and then determine the other elements. So again, the equation of the parabola, let me write in here. So that is y minus 3 quantity squared is equal to negative 8 times x plus 2. Okay, so the vertex is at negative 2, 3, negative 2, 3. So negative 2, 3. Okay, let's just be resourceful with our graphing paper. So this is the vertex, negative 2, 3. And then the value of A is 2. And the parabola opens to the left, right? So for us to be able to find the focus, we have to count 2 units to the left. Okay? Again, let's determine this one. This is the vertex. The coordinates of the vertex are negative 2, 3. And then determine the focus. That's 2 units to the left. So 1, 2. Our focus will be at this point. Okay, let's use the blue one. Okay, so the coordinates of the focus will be negative 4, 3. Then what about the directrix? The directrix is also 2 units from the vertex. So you have 1, 2. So it's here. Okay, so this point is one of the point of the directrix. So therefore the directrix is x equals 0, or the y-axis. So let's say we have this one line here. Then next is we have to determine the ends of the latus rectum. Okay. The ends of the latus rectum. So it's the latus rectum is equal to 4a, so that's 8. So meaning to say it's 4 units up and 4 units down from the focus. So you'll have 1, 2, 3, 4. So at this point at negative 4, 7. And then 4 units down also. So 1, 2, 3, 4. So at this point. Let's determine the coordinates. So we'll have negative 4. Pasensya na ka guys sa ingay ha. Mga aso. Negative 4, 7. And then, love here, negative 4, negative 1. So we have L, we have R. Okay, then let's connect these points, this latus rectum, the dashed lines. Okay, so now we can draw our parabola. So again, the parabola opens to the left. Okay. There you go. And then we have to draw our axis. The axis is a line that is perpendicular to the directrix and contains the focus and the vertex. Okay, so we have the axis. Now we can determine the points again. So the equation of this axis would be, what's this? That's correct. So this is y equals 3. And the equation of the directrix again is x equals 0. So there you go, guys. We have the following elements. This is the graph of y minus 3 quantity squared equals negative 8 times the quantity of x plus 2. Again, this is the graph of the parabola with equation y minus 3 quantity squared equals negative 8 times the quantity of x plus 2. And these are its elements. The vertex is at negative 2, 3. The focus is at negative 4, 3. The ends of the latus rectum are at negative 4, 7 and negative 4, negative 1. The directrix has the equation x equals 0 and the axis is y equals 3. Let's have our second example. The equation given is x squared plus 6x plus 8y equals 7. So you notice that the equation is not in standard form. It is in general form. So we have to express this equation in standard form by again using the completing the square. So in transforming this equation to standard form, first is retain the variables with x in the left hand side of the equation and move the other terms to the right hand side of the equation. So this would be x squared plus 6x equals negative 8y plus 7. Next, we have to complete the square for x squared plus 6x. What are we going to add in here to make this a perfect square? That's right, it's 9. So you have x squared plus 6x. So how did we get 9? This is 6 divided by 2, that's 3. Square it, so that's 9. So x squared plus 6x plus 9 is equal to negative 8y plus 7. Since you have added 9 on this side, you have also to add 9 on this other side. Okay. Then express this one as a square of a binomial. So the square root of x squared is x. Copy the sign. Then the square root of 9 is 3. Then square it. And then simplify this. We'll have negative 8y plus 16. Then copy x plus 3 quantity squared. Simplify this one. Negative 8 is common, so you can factor it out. Negative 8 times the quantity of, this will be y. Then 16 divided by negative 8 is negative 2. So you'll have y minus 2. So if you're going to multiply negative 8, you'll have 2y minus 2. That would be negative 8y plus 16. So we now have the standard form of the equation. You have x plus 3 quantity squared equals negative 8 times y minus 2. So, what is the vertex? What is the vertex of our parabola? We'll have, okay, it is negative 3, 2. And where's the opening of this parabola? I mean, what is the standard form of this parabola? So that is x plus h quantity squared equals negative 4a times the quantity of y minus k. In other words, the opening of the parabola is, where's the opening? It's negative, and what's being squared is x, so the opening is downward. The parabola opens downward. Now we are ready to graph this equation, okay, this parabola. Let us write here again our equation. The standard equation is x plus 3 quantity squared equals negative 8 times the quantity of y minus 2. Again, this is just one of the strategies, guys, in graphing. So you can just determine the value of the vertex and the value of A. Then you can sketch the graph. Okay. Again, so we have the vertex. The vertex is at negative 3, 2. That's right here, negative 3, 2. And the value of A is, also 2. Okay. Okay, there you go. So let's plot the points now for the vertex. The vertex is at negative 3, 2. Okay, negative 3, 2. It's here. Okay, let's write here. This is the vertex. It's negative 3, 2. And since the parabola opens downward, to determine the focus, we have to move 2 units down. Okay, so 2 units down, we'll have 1, 2. It's here. 1, 2. And then, so we have the focus. What are the coordinates of this focus? You'll have negative 3, 0. And what about the directrix? It's also 2 units from the vertex. So the vertex is located on the opposite side of the parabola's opening. It's also 2 units from the vertex. You'll have 1, 2. So it's here. Okay. Then you can draw the vertex, or the directrix, I mean. And then next is the latus rectum. Okay, so the latus rectum has length 8. It's also equal to 8, just like in our first example. So it's also from the focus 4 units to the right and 4 units to the left. So let's count. You have 1, 2, 3, 4. So it's here. Then the other end, you have 1, 2, 3, 4. Okay. Then we can now draw our parabola, and it opens downward. Okay. Okay, so let's now determine the, still have to draw our axis. Okay, so let's determine the equation of the axis. What's the equation of this axis? It passes through x equals -3. So therefore, the equation of the axis is x equals -3. What about the equation of the directrix? Okay, so this is, the equation of this is y equals 4. Then we have here the ends of the the ends of the latus rectum. You have -7, 0, and this has coordinates 1, 0. There you go. We have the elements of the parabola with the equation x squared plus 6x plus 8y equals 7. This is the standard equation, and this is the graph. Let's now have our third example. The given equation is 16x squared plus 72x minus 112y equals -221. So the same with our second example. This equation is not in standard form yet. It's still in general form, so we have to transform it. Okay, so since the numerical coefficient of x squared is 16 and not equal to 1, we can divide everything by 16. So our equation now would be x squared plus 72 and 16. Okay, there's a common factor which is 8. Okay, so this would give us 9 over 2x minus 112 and 16, 112. Okay, there is a common, let's say 112. 112 is 8 times 14. 16 is 8 times 2. So can cancel this one, so 7. So I have 7y equals -221 over 16. Next is we can retain x squared. We can retain x squared plus 9 halves x in this left hand side and move the other term -7y to the other side. We can have x squared plus 9 halves x equals 7y minus 221 over 16. Okay. Next is we have to complete the square to make this a perfect square trinomial. So what are we going to add in here? Okay, so that's 9 over 2 divided by 2 is 9 over 4. Then square 9 over 4, that gives us 81 over 16. So we will add we will add 81 over 16 on this side. Then copy 7y minus 221 over 16. We also have to add 81 over 16. Then write the factor. What's the factor? You have x plus the square root of 81 over 16 is 9 over 4. Have 9 over 4 quantity squared equals 7y minus, this is negative 221 plus 81. Negative 221 plus 81. So this is 140. This is 0. This is 12, so 4. So 1. 140 over 16. And 140 and 16 has still common factor, that is 2. That's 2. That's 4. Okay, so 140 divided by 4 is 35. Then 16 divided by 4 is 4. Okay. Then we can simplify this further. I'll have copy this one, x plus 9 over 4 quantity squared equals factor 7. Factor 7 from 7y and factor 7, so that we will just have here y, and then 35 over 4 divided by 7. So what are we going to multiply to 7 to come up with 35 over 4? That is 5 over 4. So there you go. This is the standard form of the equation given 16x squared plus 72x minus 112y equals negative 221. Look at this equation. Okay. The parabola is opening. That's right. The parabola opens upward and it has the vertex. That's the vertex negative 9 over 4, positive 5 over 4. This is the vertex. Now we can graph it. Okay, so let us write here again the equation, the standard equation. So we can have, you have x plus 9 over 4 quantity squared equals 7 times the quantity of y minus 5 over 4. That's the equation. And the vertex, so in order for us to plot the point, we can write our vertex as decimal. So the vertex is negative 9/4 and 5/4. So negative 9 divided by 4, that is negative 2.25. And 5 over 4 is 1.25. So that's our vertex. So we can plot that point. And then, where is that? Negative 2.25, 1.25. That is in the second quadrant. Something here. And then 1.25. Can probably write it here. Okay, the vertex is at this point, negative 2.25 and 1.25. Okay, so since the parabola opens upward, the focus would be a units above the vertex. So let's determine the value of A. So since 4A is equal to 7, A is equal to 7 over 4, or 7 over 4, or A is 1.75. So that's 1.75 units from this point. Okay, so 1.75 up. So we are going to add 1.75 to 1.25 kasi yung height eh, 'di ba? Yung height. So the same pa rin yung x, negative 2.25. So 1.25 plus 1.75, that's 3 units, okay? That's 3. So meaning to say, our focus is located at this point. So the coordinates of the focus would be, at negative 2.25, 3. Now what about the directrix? The directrix would be 1.75 units below the vertex. So that's 1.25 minus 1.75, pababa. So what's 1.25 minus 1.75? That is negative 0.5. So it's here, okay? What would be the coordinates of this point? Okay. Anyway, that will just be our guide for us to determine our directrix. So we have here the directrix. Then what about the latus rectum? Again, the latus rectum is located at this line here that I'm referring. So since the latus rectum is the length of the latus rectum is equal to 7, so that's 2a units to the right, 2a units to the left. So that's 1.75 times 2, it's 3.5. So let's count. So that's negative 2.25 plus 1 plus 3.5 plus 3.5. So that would be 1.25. It's here, 1.25. Okay, the coordinates would be 1.25, 3. And what about the other end? What about the other end? That is negative 2.25 minus 3.5. That would be negative 5.75. So somewhere here. Okay. So natakpan na siya. So the coordinates of this point are negative 5.75, 3. Then we can draw the latus rectum. Now we can draw our parabola. Sketch the graph smoothly. Then we have the axis. Don't forget the axis. So what is the equation of the axis? The axis has the equation x equals negative 2.25. What about the directrix? What's the equation of the directrix? This is y equals negative 0.5. Okay, so again we have the vertex at negative 2.25, 1.25. The focus is at negative 2.25, 3. The ends of L are at negative 5.75, 3. Then 1.25, 3. The axis is x equals negative 2.25 and the directrix is y equals negative 0.5. Thank you. For your guide, guys, in determining the elements of the parabola in any form, I prepared here the formulas. So we have here, when the standard form is, let's say, y minus k quantity squared equals negative 4a times the quantity x minus h. So the vertex is at hk, opening to the left. The focus has the formula h minus ak, directrix x equals h plus a, ends of L are h minus a, k plus negative 2a, and axis y equals k. So this can serve as your guide in determining the elements, okay, the coordinates of the focus, the vertex, and ends of LR, and also the equation of the directrix and the axis. So this can serve as your guide. Okay. This time it's your turn, guys. Try this. Number 1, y squared minus 2y minus 12x plus 13 equals 0. Then number 2, 3x squared minus 30y minus 18x plus 87 equals 0.